James Webb confirms the discovery of its first exoplanet. Welcome to the enthralling world of exoplanet discovery. We are pleased to announce the confirmation of LHS 475b, the first exoplanet identified by the James Webb Space Telescope. This distant world is nearly the same size as Earth and is located 41 light-years away in the constellation Octans. The James Webb Space Telescope, which was launched in 2021, is the world's greatest space observatory. It is outfitted with cutting-edge infrared cameras and spectrometers, allowing it to perform astonishingly precise measurements of stars and planets. Because of its close proximity to Earth, scientists are very excited by LHS 475b. This makes it an excellent target for exploration and further research. We are beginning to understand the conditions required for planets to support life, and each new discovery, such as LHS 475b, brings us closer to that goal. Exploration of exoplanets is one of the most exciting endeavors of our time. We are steadily unveiling the mysteries of the cosmos with the James Webb Space Telescope and other cutting-edge equipment. Perhaps our descendants will visit LHS 475b in person one day. We will continue to observe this mysterious planet from afar until then. Join us as we explore the mysteries of this distant planet and their implications for our own solar system. From transits to spectra, we'll explain the current research being conducted to uncover the secrets of our cosmos. It has long been established that our solar system is not alone in the universe, with new exoplanets discovered every day. A new exoplanet named LHS 475b has been confirmed by the James Webb Space Telescope today, which is an exciting discovery. It's in the constellation Octans, which is 41 light-years away. The fascinating thing is that, at 99% of its circumference, it is virtually exactly the size of our planet Earth. This is a significant breakthrough in our understanding of the universe, and the implications could be far-reaching. The planet completes a complete orbit around its star in 2 Earth days, making it ideal for observation. We were able to see 2 complete transits. Researchers using NASA's JWST have made an exciting breakthrough in their quest to discover and study rocky exoplanets orbiting red dwarf stars. What is the significance of this? Although red dwarfs are much smaller and less powerful than G-type stars like our Sun, their size and energy output make them useful for detecting exoplanets. Due to the fact that red dwarf stars live longer and have relatively low radiative power, their exoplanets, such as those in the TRAPPIST-1 system, Proxima Centauri, and Barnard star, are closely studied for the potential of habitability. Since they typically orbit much closer than planets around other stars, they are considered viable candidates for habitability that could exist for a very long time. The James Webb Space Telescope has enabled researchers to observe planets smaller than Jupiter for the first time, potentially leading to new discoveries about the Milky Way galaxy. With the confirmation of LHS 475b by the James Webb Telescope, scientists and researchers can now begin to focus more of their attention on studying the rocky exoplanets orbiting red dwarf stars. This research will help us better understand the complexity of our universe and hopefully, one day, lead us to discovering Earth-like habitable planets. Nevertheless, there are 2 issues to consider with the hypothesis of red dwarf exoplanets being capable of sustaining life. One of the discoveries made is that many of the planets close to their star are tidally locked, meaning that only one side of the planet is always facing the sun. A planet that is tidally locked could potentially be habitable, yet it would certainly present a challenge. It is particularly significant to note that red dwarf stars emit a large number of potent solar flares, especially during their earlier stages of life. These intense radiation and particle flares could be detrimental to any life on a dwarf exoplanet, and may even permanently sterilize the atmosphere of the planet. Although observations have not suggested that this scenario is certain or even present, the red dwarf flaring has been documented extensively. Thus, the flares may have made it seem improbable for life to exist on approximately 3/4 of the stars in our galaxy. How do we know if a distant planet is present? One of the main methods is called the transit method. The transit method detects the presence of a nearby planet orbiting a star. Scientists measure the light coming from the distant star and look for regular changes in the star's brightness. If a planet is orbiting the star, it can block a small fraction of the star's light. As the planet passes in front of the star, it will cause a decrease in the star's brightness. By watching for this decrease in brightness, astronomers can detect the presence of a distant exoplanet. So what did James Webb do to contribute? The James Webb Space Telescope is like our eyes in space. On the 31st of August, 2022, when it looked at a star called LHS 475, it saw something special. A planet was traveling across the star, like a shadow. By watching how the star's brightness changed over time only when the planet passed, we can learn more about this planet. The infrared telescope was able to detect the exoplanet LHS 475b by studying 2 of its transits across the star thanks to the sensitivity it's dotted with. As you can see in this gorgeous plot, taken from the telescope's near-infrared spectrograph, illumination from LHS 475 is being blocked as the planet is transiting it, causing the light curve of the star to significantly diminish. It goes back to normal, which is the first sign that the drop is due to an exoplanet and not to inherent variation in the star's brightness. What's the next step after such a discovery? Of all the ongoing telescopes, only the James Webb Space Telescope is equipped with the ability to characterize the atmospheres of exoplanets the size of Earth. Researchers use data to study the transmission spectrum of the newly identified Earth-sized terrestrial planet, but are still unable to observe much yet, whether or not it has an atmosphere. An atmosphere is made up of numerous gases, and it may tell us a lot about the planet, whether it can hold life, and how it might evolve. Scientists are trying to figure out if this planet has an atmosphere so they can see if it is a good area for us to explore. What's a transmission spectrum? A transmission spectrum is like figuring out what distinct colors are in a rainbow. When a planet passes in front of a star, the planet's atmosphere can function like a colored filter, making the starlight look different. By looking at how the light changes, scientists can figure out what colors are in the atmosphere of the planet. This graph tells us how much light is blocked from a star when we gaze at the planet from different distances. Different chemicals in the planet's atmosphere make the planet look bigger at certain distances. If we don't notice any wider distances in this graph, it suggests that there are no molecules in the planet's atmosphere. The researchers was unable to determine the type of atmosphere existing on exoplanet LHS 475b, but they can reject the presence of a terrestrial-type atmosphere like methane, similar to that of Saturn's moon, Titan. A flat line in a transmission spectrum, such as this one, can be highly exciting because it can offer us with a plethora of information about the planet. As this spectrum suggests, Webb did not discover any element or molecule in a substantial quantity. Spectroscopic signs of hydrogen in an exoplanet's atmosphere, such as LHS 475b, are usually indicative of a light, gaseous atmosphere. These elements, however, were not found in the exoplanet's spectra. The green line indicates that the methane atmosphere does not block enough light in the 3.3 micron band, implying that the planet does not have a methane atmosphere. The yellow line depicts the model which the best represents a featureless spectrum with no atmospheric evidence of the planet. This model is suggestive of a planet without an atmosphere. The team also admits that, while the planet may not have an atmosphere, some atmospheric compositions, such as a pure carbon dioxide atmosphere, have yet to be ruled out as possibilities. Many disputes have been continuing over the difficulties of identifying the presence of a 100% carbon dioxide environment. According to the researcher, Lustig Jaeger, it is counterintuitive because the atmosphere is so dense that it is difficult to detect using the instruments available. This summer, the team intends to collect further measurements that will provide them with more exact readings for identifying carbon dioxide atmospheres. The James Webb Space Telescope discovered clouds on the exoplanet, implying that it is comparable to Venus, with a carbon dioxide atmosphere and heavy clouds. The planet is also far warmer than Earth, raising the prospect of a Venus-like atmosphere. We've only begun to scrape the surface of the cosmos. We can now confidently confirm the existence of a planet that could potentially sustain life thanks to the James Webb Telescope. We can only hope that further research and exploration of LHS 475b will aid us in unraveling the mysteries of our cosmos. Until then, we can be confident that the future of exoplanet exploration is bright. So, until then, let us continue to study the skies while keeping an eye out for aliens. Alright everyone, you've reached the end of this video. If you have your own theory about whether there is life outside of Earth, please share it in the comments. Thanks for watching.